children. Now today we will discuss with another topic, that is in energy, that is about the practical machine and the ideal machine. So the practical machine, also known as the actual machine. Now there is a difference in a practical machine and the ideal machine. Now the meaning of the term ideal machine is the machine which are not in use. And practical machine, the machine which we use. Okay, and we use machine, you know that we use machine in order to make our work easier or faster. So when we come to this practical, this idle machine are such that the efficiency is equals to 1 over 100%, and the work input is equals to work output, and mechanical advantage is equals to velocity ratio. So the three things you will have in a idle machine. So in idle machine, the efficiency is always 100%. Mechanical advantage is equals to velocity ratio, and the work output is equals to work input. So these things you will find in a idle machine. And in a idle machine, you can make idle machine by yourself. How you can make is, you purchase any machine and you keep it, you don't use it. Okay, you don't use that machine. After a year, after a month or a year, now these machines, they stop functioning. Let us consider about the complex machine. Okay, like you purchase a car, a new car, you purchase it, and you keep it on a car park. You don't use, you don't ride it. 1 month, 2 months, 3 months, you keep on you keep it on the same place in the car park. So after a year, what will happen? The tire get punctured, the rust start taking place, the different machinery parts, in the different machinery parts, the rust will start occurring. The machine becomes very stiff, it doesn't move. Okay, and also the battery will also, it goes down, and finally that car, it becomes useless. It becomes useless. That means you won't be able to move, or you won't be able to ride the car. So this is how the idle machine. This is how we call it as idle machine. So idle machine, in practical case, idle machine does not exist. There is no such idle machine. When we purchase a machine, we purchase in order to make that machine to work. We don't just purchase a machine just for a show. Okay, you will use it. You at home also, you have got so many machines. Okay, like simple machine as well as a complex machine. You have got hammer, scissor, knife, blade. Okay, fire guns, forceps, sugar guns. So all of these, they have some use. You will use it. One day you will use it. If you want to pierce a nail in the wall or in a wooden plank, for that you will use hammer. So hammer you will keep it at home, knife you will keep it at home. Okay, so all these machines, they work, they have some use. Even this television, refrigerator, washing machine, all of them have got use, and you will use it. If you don't use, then what will happen? The machine, finally they get spoiled and it becomes useless. Okay, that means they won't be able to perform any work, because the rust start taking place, start occurring there. Okay, the different machinery parts also doesn't function properly. Okay, and these things will happen here. So therefore, we call it as an idle machine. And this idle machine, there are no such idle machine in practical life. That means practically, in our practical life, there are no such idle machine. So therefore, idle machine, we can say that idle machine really do not exist. Idle machine really do not exist. So in idle machine, you will find all these things. That is, the efficiency is 100%. Mechanical advantage equals to velocity ratio. Work output is equals to work input. All these things you will find it in an idle machine. And the idle machine, finally, the idle machine do not really exist in our practical life. But when we consider this practical machine or the actual machine, this machine exists in our life. They always exist. They really exist. And in practical machine, the efficiency is always less than 100%. Efficiency is not 100%. Here we are finding, we are getting efficiency 100%. Here the efficiency is less than 100% or less than 1. Now why the efficiency is less than 1 is that in practical machine, the practical machine is the machine which are always in the use. You use that machine. So always in practical machine there is a loss of energy. There is a wastage of energy. And this wastage of energy is due to the friction between the different machinery parts. Okay, there is a loss of energy, and this loss of energy is due to the friction. Friction always exists between the two bodies, you know that. Okay, so different machinery parts, there is a when the machine they start working, they start functioning, the different machinery parts of that machine will produce a friction rate. Okay, and due to that friction, there is a loss of energy. And this loss of energy is in the form of heat and sound. Okay, this loss of energy, or we call it as dissipated. The energy is dissipated in the form of heat and sound. The same example I will give you, a vehicle. If you ride a vehicle, the vehicle gets heated up, you know that. Okay, and the sound is also produced there. And why that heat is produced in a vehicle? Due to the friction between the different machinery parts in a vehicle. So, in practical machine always the efficiency is less than 100%. Okay, efficiency is not 100% because there is always in every machine there is always a loss of energy, and this loss of energy is in the form of heat and sound. And loss of energy is due to the friction between the different machinery parts. Then the next point is there, mechanical advantage is always less than velocity ratio. In practical machine, mechanical advantage is always less than velocity ratio. And work input is less than work output. Okay, that means the work input means the work done on the machine. Work output means work done by the machine, and always the work done by the machine is greater than the work done on the machine, because the machine will do a large amount of work by applying a small force or by applying a small effort. So this is how the difference has come between the idle machine and the practical machine. Okay, so and the practical machine and whatever the machine which we are using in day-to-day life to make our work easier, so that is the practical machine. Because there is always, when we use a machine, either a simple machine or a complex machine, always there is a form, there is a loss of energy in the form of heat or sound, okay, or there is a due to the friction between the different machinery parts. Even if you use a hammer, okay, the portion where you strike a nail through that hammer, that portion becomes heated up. Okay, because you are using the hammer, and how you are using is that you are hammering the nail in order to pierce the nail on the wall or on a wooden plank. So therefore, the practical machine always exists in our actual life, in our actual practical life. Always there is a practical machine, and idle machine cannot exist. So next point, let us come to the lever. L-E-V-E-R, lever. Okay. Now the lever is also a simple machine. Now the lever is a thin, it is a straight or a bent bar. Okay, it is a straight bar, it is a straight, it is a rigid, means are very strong. It is a rigid, straight or a bent bar. The bar along rod you can take, a long iron rod, that is considered as a lever. Now when we define lever, it is a rigid, okay, thick, straight or a bent bar capable of turning around a fixed point called fulcrum. Now this lever is capable to turn around a fixed point called the fulcrum. And fulcrum, you know that fulcrum is a point on the machine in which the machine rotates on its fixed axis. Within that fulcrum, the machine will move or rotates. Okay, like last time I gave you the example of a scissor, a pair of scissors. In a pair of scissors, at the center there is a screw, and that screw will hold the two blades of a scissor. If you remove the screw, or if you open the screw, the blade gets separated, and they do not act as a scissor now. And it will become very difficult to cut a paper or a cloth. Okay. It becomes very difficult. So therefore, now that point where the two blades of scissor are fixed, that point is the fulcrum. So therefore, when we come to the lever is a simple machine. It is a simple machine, and the definition of lever is a thick or a thin, straight or a bent, rigid bar capable of turning around a fixed point called the fulcrum. Okay, now this is about the lever. Now let us consider this diagram. Follow this diagram. I have drawn a straight rod here, a straight bar, which we call it as a lever. And here is a fulcrum. Suppose if I take a fulcrum at the middle of this bar. Okay, and one side I will keep the load, and another side I will keep the effort. Okay, always in a lever, the three things are located here. One is the fulcrum, other one is the load, and other one is the effort. And effort is the force which you apply. Load is the object which it moves. Okay, like for example, take a stone is a load. To lift a stone, you take a long rod, and that rod we call it as a crowbar. That we call it as a crowbar. C-R-O-W-B-A-R, crowbar. Now crowbar is a lever, and it is a long iron rod. So with the help of the crowbar, what you can do, you can lift a stone, a heavy stone, a huge stone. You can lift it. Okay. So and the force which you apply in order to lift the load, that is a stone, that is the effort. And the stone which moves by applying the effort, that is the load. So in the lever, the 3 points you have to remember. One is the fulcrum, other one is the effort, and the load. Now, since the fulcrum is between the load and the effort, that is at the middle, let us consider at the center. Now from here, the two things you have to remember. One is the effort arm and other one is the load arm. Now the effort arm, now let us come to the first point, effort arm. Effort arm is the distance from the fulcrum to the load, this distance. The distance from the fulcrum to the effort, the distance from the fulcrum to the effort is known as the effort arm, and the distance from the fulcrum to the load is known as the load arm. Okay, another point is there, that is effort arm and the load arm. So far, we have only learned about the load and the effort. Now the next point has also become here related to the lever, effort arm and the load arm. So effort arm I will write here EA, that is effort arm, and load arm I will write here LA, that is load arm. So effort arm is the distance from the fulcrum to the effort is the effort arm. The distance from the fulcrum to the load is known as the load arm. So in the lever, you will find again two more things are there. One is the fulcrum, other one is the load, effort arm, and the load arm. Okay, so this is about the lever. And the next point is here, that is how a lever balanced. How a lever balanced. Now the next point will come to how the lever get balanced. Okay. Now how much force you will apply to lift a load. Okay, to lift, suppose you take a stone, to lift a stone, how much effort or how much force is needed? And that force needed depends upon the load arm and the effort arm. Okay, now the next point is here, to lift a load, okay, you need to apply force, you need to apply effort. Okay, and how much effort you will apply? It depends upon that. And the next point is there, to lift a load, okay, it depends upon the effort arm and the load arm. That it depends upon the distance from the fulcrum to the effort and distance from the fulcrum to the load. So if the effort arm is more, that means the distance from the fulcrum to the effort is more and the distance from the fulcrum to the load is less. That means if the effort arm is more and the load arm is less, means if the load is very near to the fulcrum and the effort is very far away from the fulcrum, so it becomes easy to lift a load. Remember that it becomes very easy to lift a load if the load arm is less and the effort arm is more. Okay, so that means if the effort arm is more, it becomes very easy to lift a load by applying a less effort. Okay, so therefore, in that case, the lever will get balanced. So in order to balance the effort, okay, there should be the load, effort arm and load arm. And therefore, what the effort arm should be greater than that of the load arm. So now there is a relation between. There is relation between the load, effort arm and the load arm, and this relation is known as the principle of lever. Is known as the principle of lever. So according to the principle of lever, it is stated that load into load arm equals to effort into effort arm. This is the principle of lever. Load into load arm equals to effort into effort arm. So from here, what you can do is that mechanical advantage equals to load. Now I will write the load, then divided by effort, then I will write the effort arm divided by load arm. Okay, now this load divided by effort is mechanical advantage. Then again, if the load arm and effort arm is given, you can calculate mechanical advantage another way also. Two ways you can calculate mechanical advantage. If the load and effort is given, then you can find mechanical advantage equals to load divided by effort. If the effort arm and load arm is given, then you can calculate mechanical advantage effort arm divided by load arm. Now, why I am writing effort arm at the numerator and load arm at the denominator is because effort arm is should be more than the load arm. If the effort arm is more than the load arm, then in that case the lever will get balanced. Okay, so therefore this load upon effort is equals to effort arm equals to load arm is equivalent to mechanical advantage. So effort arm divided by load arm is equals to mechanical advantage. So this is the principal lever, and depending upon the principal lever, how the lever can be balanced. Okay, so depending upon the distance of the effort arm and the load arm, and also the force which you will apply. Understood? So this is about the ideal machine and the practical machine and the principle of lever. Now the next one will come to the types of lever. Now depending upon the position of fulcrum, load and effort, the lever is classified into three classes. They are class 1 lever, class 2 lever and class 3 lever. Now in class 1 lever, the fulcrum is between the load and effort. Fulcrum is between the load and effort. So in class 1 lever, now example I will give you, a beam balance. You know the beam balance. So one side will keep a weight, other side will keep the load. Okay, and these are used by the grocer or the shopkeeper to weight the commodities. Okay, you can find there. So beam balance is an example of class 1 lever, as well as a pair of scissors, crowbar. Just now we have discussed that crowbar, a long rod, which are used to lift a load. So crowbar, beam balance, a pair of scissors, even a seesaw. Seesaw, you know, you will find in a children park. Okay, where the small children they play. That is a seesaw. It is also class 1 lever. Now in class 1 lever, the fulcrum is between the load and the effort, and the effort arm in class 1 lever, the effort arm is equal to that of load arm. It can be, the effort arm can be equal to load arm. Now this effort arm and load arm becomes equal when the fulcrum is at equidistant from effort and the load. Okay, if the fulcrum is at the center, so that equal distance from the load and the effort, then the effort arm and the load arm will become equal. So in class 1 lever, effort arm can be equals to load arm. Effort arm can be less than load arm. Another point, effort arm can be less than load arm. So how the effort arm can be less than load arm is, if the fulcrum is here near the effort, then the distance from the fulcrum and the effort become less. So effort arm will become less and the load arm will become more. Or load arm can be less than the effort arm. So three things can occur here. Effort arm and load arm can be equal. Effort arm can be less than the load arm if the fulcrum is somewhere here near to the effort, and load arm can be less than the effort arm if the fulcrum is near to the load. So three things can take place here in class 1 lever. In class 2 lever, the load is between the fulcrum and the effort. So example of class 2 lever is a wheelbarrow, number 1. Second one is a nut cracker, and also the other example is there, that is bottle opener. Bottle opener is there. Okay, so this is an example of class 2 lever. Now in a class 2 lever, the load is between the fulcrum and the effort, and always in a class 2 lever, the effort arm is more than the load arm. Okay, effort arm is more than the load arm because the fulcrum and the load are at the extreme end. They are located at the extreme position. So wherever you keep the load, always the load arm will become less than the effort arm. So in class 2 lever, remember that the one condition happens here: effort arm is always greater than the load arm, or load arm is less than the effort arm. In class 3 lever, effort is between the fulcrum and the load. So in a class 3 lever, the load arm is always greater than the effort arm. Since the effort is between the fulcrum and the load, wherever you keep the load, either you keep it near the wherever you keep the effort, either you keep the effort near the load or equidistant. Okay, wherever you keep, the load arm is always greater than the effort arm. An example of class 3 lever is a fishing rod, a fire tongue, sugar tongue. Okay, all these are the example of class 3 lever. So these are the different types of lever. So depending upon the position of the fulcrum or position of the fulcrum load and the effort, there are various types of lever, and this lever can be classified as class 1 lever, class 2 lever, and class 3 lever. So in the next class, we will come to another type of simple machine, that is the inclined plane, wheel and axle, weights, screw, and also the pulley. So in the next class we will continue that. Okay. So today we'll come to the end of this class. Thank you.